Okay, so hi everyone. Myself Aishan Tripathi, a DSM Internet problem setter at Geeks for Geeks, and welcome you all to this post analysis of BioWizard School coding contest. So let me check that whether I am audible or not.
And welcome you all to this post analysis of BioWizard School coding contest. So let me check that whether I am audible or not. Welcome you all to this.
Okay. Okay, so we would be starting in few minutes.
In few minutes.
Okay, so let's get started with the quiz section first. Okay, so let me share my screen first. Okay, all right. So let's start with the quiz section. Uh, yep. So we would be starting with the aptitude section only, and then we move on to the programming logic quiz section, and then coding problems. All right. So we start with the very first question. So the first question, the problem statement goes like this: that we have the speed of train is going from Agra to Delhi is 120 kilometer per hour, while when coming back from Delhi to Agra, its speed is 180 kilometer per hour, and our task is to find the average speed during the whole journey. So the problem was just based on formula. You just have to put the values in the formula. So let me move to the board. Yep. So we just have to use the formula of harmonic mean formula to find the average. So let me write over here harmonic mean formula to find the average speed. All right. For average speed. And the formula is we just have to multiply 2 into S1 into S2 divided by S1 plus S2, and here S1 and S2 are speed. So let me write copy the value from here. So the speed of the train going from Agra to Delhi is 120, and for returning back its speed is 180. So the value of S1 is 120 and the value of S2 is 180. So we just have to put the values. So let me write over here. S1 is equal to 120, all right, and S2 is equal to 180. So 2 into 120 multiplied by 180 divided by 120 plus 180. So this would be 2 into 21,600 divided by 300. So this gets cancelled out and we get 144 as an answer, which is average speed. So let me mark 120 here. Okay, it's not actually 120. Okay, it's 144. Yep, sorry. So we have to mark 144 here. So let me submit it. So correct answer. Let's move to the next question. So in the next question, num the average of 120 numbers is 70, and when 10 more numbers are added, the average of 130 numbers become 76, and our task is to find the average of those 10 numbers. All right. So let's move to the board and let me clear all these things. So let's say average of 120 numbers, or let me write it this way. numbers is equal to 70. This was given to us that average of 120 numbers is 70. So we can easily find the sum of 120 numbers. We can simply use the formula, that is average is equal to sum divided by n. That is sum of average is equal to sum of n numbers divided by n. So we simply use the formula. So here the value of n is 120 and the average is 70. So total sum total sum of 120 numbers is 120 is equal to 120 into 17. We just multiply this, that is sum is equal to average multiplied by n, and here the value of n, or maybe let me change the color. All right, yep. And the value of average is 70 and the value of n is 120. So its sum is going to be 8400. All right, and then we are given the average of 130 numbers, which is 70. So similarly we can find the sum of 130 numbers. So I'm just reusing this formula. So total sum of 130 numbers is equal to average, and average is 76 multiplied by n, and here the value of n is 130 in this case. So we just multiply 130 multiplied by 76, and this is equal to 1480. Now we can easily find the sum of 10 numbers, those 10 numbers that were added. And previously we have 120 numbers and now we have 130 numbers. So we can just subtract the sum of 130 numbers. Oh, sorry to say, but it's actually, I guess, 400, 14,800, or okay, okay, let me calculate this using calculator. All right. So 130 multiplied by 76. So this was 9,880. 9,880. So 9,880. And now we can easily find the sum of those 10 numbers that were added. So the sum of 10 numbers is equal to sum of 130 numbers, which is 9880, minus sum of 120 numbers, which is 8400, and this is equal to 1480. And now we have a sum and we have the value of n, so we can easily find the average by just using this formula, that is average is equal to sum divided by n. So average of 10 numbers is equal to 1 1480 divided by 10, which is equal to 148. So 148 would be the correct answer. So let me mark 148 here. Yep. All right, correct answer. Now let's move to the next question. So here in this problem, okay, so the problem statement goes like this, that if a woman were sell her mobile phone for 7,000, she would lose 30%. And to gain 30% extra, she should sell it for. We have to check that at what amount she should sell such that she get a profit of 30%. All right. So let me clear these things. Okay, so let's say the original value was x. Original value is equal to x, and after selling at the price of 7,000. Okay, let me check. Yeah. At the okay, after selling at the price of 7,000, she would lose 30%. All right, that is after selling the cell phone at the price of 700, she would lose 30%. So 0.7x is equal to 7,000. That is 70% of the original price she get. So the original price was x, so 70%, which is 0.7x, is equal to 7,000. So now we can easily find the value of x, which is equal to 17 7,000 divided by 0.7, which is equal to 10,000, right? So this would be the original price. And now our task is to find that at what price she should sell the phone such that she gets a profit of 30%. All right. So now we find the 30% of the original price of phone. So 30% of it. Okay. So let me change the color. So the 30% of 10,000 is going to be. So let me put it over here. 30% is equal to 30 multiplied by 10,000 divided by 100. So this gets cancelled out, and the 30% is equal to 3,000. So at what price she should sell? So 10,000 plus 30%, that is 3,000. So the 30,000 is the correct answer. All right. So let me mark 30,000 and let's see what we get. Okay, so 30,000 is a correct answer. So now let's move to the next question. So in this question, we are given the angle of depression of a car standing on the ground from the top of the 125-meter tower is 45 degree, and we need to find the distance of the car from the base of the tower in meter. So let's move to the board. So basically the height of the tower. Okay, yeah. So the height of the tower is 125 meter. All right, and the angle of depression of car is 45 degree from the top of the tower. That is this angle. This angle is given to us, which is 45 degree. All right, and our task is to find this one. Let's call this base as b, and this forming a right angle triangle, so we simply use the formula of tan, and this would be our perpendicular. So recall the formula of tan, that is tan theta is equal to perpendicular by base, that is p by b. All right, so p is given to us, theta is given to us, that is tan 45 is equal to 125 by b. So we can easily find b. B is equal to 125 divided by tan 45, and the value of tan 45 is 1. So our base is equal to 125. All right, clear to everyone? Okay, so we simply mark 125 as a correct output. Okay, so we get a correct result. So in the fifth problem, our task is to find the length of diagonal of a square plot whose area is equal to the area of rectangular plot of 80 meter and 40 meter, right? So basically, area of a square is equal to area of rectangle, and for this rectangle, length and breadth is given to us. That is, length is equal to how much it is. The length is equal to 80 meter and breadth is equal to 40 meter. Length is equal to 80 meter and breadth is equal to 40 meter. So let me draw the rectangle here. That is, its length is 80 meter and its breadth is 40 meter. So now we can easily find the area of rectangle, which is equal to length into breadth. Let me write over here, area of rectangle is equal to length into breadth, which is 80 into 40. All right. So the area of rectangle is equal to 80 into 40, which is 3200. All right. So the area of rectangle is equal to 3200. It means area of square is equal to 3200, and we know the formula of area of square, which is side square. That is, side square is equal to 3200. That is, each side is equal to root of 3200. All right. And if you find the square root of this 3200, then you will get somewhere around 5 56.57. And now our task is to find the diagonal of the square whose area is 56.57. So let me draw the square over here. All right. Right. So our task is to find this diagonal. This diagonal. And each height is 56.57, 56.57, 56.57, 56.57, and the diagonal of a square is breaking down the square into two right angle triangle, and this was a upper right angle triangle and this was a lower right angle triangle, and we can simply use a formula of Pythagoras to find the diagonal. So this is going to be our base. Let's call this as base, and this as perpendicular, this as perpendicular, and this as base. So we simply use the formula of Pythagoras theorem, and this is our hypotenuse. So the formula of Pythagoras theorem is h square is equal to p square plus b square, and we have the value of p and b, that is 56.57 square plus 56.57 0.57 is equal to h square. And if you solve this equation, then you will get the value as 79, somewhere around 79.92. All right. So we mark the closest value to this 79.92. So the closest value is 80 here. So we mark 18. Let's try to submit it. Accepted. Now let's move to the next question. Okay, so here the Sarita went to the library 8 days ago. All right, and she only goes to read books only on the Saturday. That is, she only went to the library on the Saturday. And now our task is to find the day of the week today. That is which day currently has. All right. So Sarita only went to the library on Saturday. All right, and she went to the library 8 days ago, and our task is to find the current day. All right, so she only went on to the Saturday, so we just take the mod with 7, because we only have our 7 days in a week. So if she went on Saturday, then after 7 days again, the day is Saturday. So we simply take the mod, that is 11 mod 7 is equal to 4. That is, before 4 day it was Saturday. So currently we have a Saturday, then the next day is Sunday, then Monday, then Tuesday, and then Wednesday. Right, so this was our first day, then second day, then third day, and then fourth day. So we just have to return the fourth day, which is Wednesday. All right, so we mark Wednesday as our answer. So let's try to submit it. Accepted. All right. Okay, just wait for a second. Okay, so we are back. Let me again check that whether I'm audible or not.
Every
Okay, so we are currently on the seventh problem. All right.
okay, so we are currently on the seventh problem.
So in this problem, 66 women can do a piece of work in 20 days. How many women would be required to do the same work in 30 days? All right. So let me clear this. Okay. So let the woman required to do the task in 30 days is n. So let me write. So 66 women can do the piece of work in 20 days. So 66 women can do the piece of work in 20 days. All right. And our task is to find the number of women required to do the same work in 30 days. So let's say n women are required, or let me change the color for this n. So let's say n women are required to do the same task in 30 days. So let's find the workload of each woman. That if 66 women are doing the task in 20 days, then what amount of days would one woman take to complete the task? So it's very obvious to see that the number of days required for one woman to complete the entire task is equal to 20 into 66, which is equal to 1320. All right, so this is the one woman's work rate, or what we can say one woman's work rate. All right, 130 days. And we also have n women's work rate, that is n women's work rate is 30 days. So we simply use a proportional technique, that is 1 by n is equal to 130 by 30, and then we cross multiply this, or we change the color. Okay, so we cross multiply this, so n is equal to, it's actually 120, 1320, 1320, 1320. So we can simply find the value of n, which is equal to, n is equal to 1 1320 by 30. This would cancel out, and this would somewhere around 44. So we simply mark 44. Okay, so 44 would be the correct output for this. Now let's move to the next question. All right. So at present, the ratio between the age of Arti and Divya is 2.3. After 8 years, Arti age will be 36. What is the age of Divya at present? All right. So let's solve this problem. So let's say the age of Arti, or maybe right over here, Arti's age is A and Divya's age as D. So we have the ratio of Arti and Divya age, which is 2 by 3, 2 ratio 3. So A by D is equal to 2 by 3. And after 8 years, the age of Arti is 36. That is, after 8 years, age of Arti, or what we can simply say A plus 8 is equal to 36. So we can just use this formula and substitute the value of A over here in terms of D. So if we do a cross multiplication, then so we simply do a cross multiplication. So the value of A is equal to 3 by 2. Okay, what we can say, it's not actually 3 by 2, it's just a 2 by 3. So A is equal to, we simply multiply D over here, 2 by 3 by D. All right, so we simply substitute the value of A as 2 by 3 plus 8 is equal to 36. And if you solve this problem, if you solve this equation, then you will get the value of D as 28. All right, so let me mark 28 as the age of Divya. Okay, it's not 28. I guess it's 38. Yes, it's 38, not 28. Or what we can do, let's solve. So we subtract 8 from 36. So 2 by 3, d is equal to 36 minus 8, which is equal to 28. And then we multiply it with 3 and divide by 2. So d is equal to 28 multiplied by 3 divided by 2. So it's actually 14. Then we simply multiply this. Okay, so the value of d is equal to 2 and it's 4. So it's actually 42. Okay, so we have 42. Okay, so the 42 is the correct answer. Now let's move to the next question. So the interest obtained on a sum of 10,000 for 2 years is 2000. We need to find the rate of percent. So the problem was just use of simple formula, that is formula of SI, simple interest. So just recall the formula of SI, or let me write over here. So the formula of simple interest, we call this as SI, is equal to principal amount, principal amount, or what we can say PA, multiplied by the rate, or multiplied by the time, and divided by 100. So we simply put the values. The principal amount is 10,000 and the simple interest is 2000, and the rate, we need to find the rate, right? And the time is 2 years, and this is constant. So if we use the formula, then we get a rate. So what we can do, let's solve this. So 2000 is equal to 10,000, or what we can do, we just multiply this by 2. So it's 20,000, and if we take 100 on the left side, then it's get multiplied with the SI. So 20,000 into rate is equal to 2000 into 100, which is equal to 3020. All right, so this gets cancel out, these two, and this gets cancel out with this gets cancel out with this. So we just get 10, that is rate is equal to 10. So let's mark 10 over here, 10%. Correct. Now let's move to the next problem. So in a 50-meter race, Ajay covers the distance in 60 seconds and Bhavai in 75 seconds. And in this race, Ajay beats Bhavai by how much meters? We need to find this in terms of meter. So Ajay covers the distance in 60 seconds. Okay. Hello. Hello, Konda. Okay. So Ajay covers the distance in just 60 seconds, and Bhavai covers the distance in 75 seconds. All right. So we first find the difference that how many seconds before Ajay arrives, then Bhavai. So 60 or yep. So time difference is equal to time difference. Okay. Yep. So time difference is equal to 60 minus 75, which is equal to minus 15. It means Ajay arrives 15 seconds before Bhavai. And now we need to find that what is the difference between the distance of Bhavai and Ajay before 50 seconds. All right. So we just need to find the distance after the 50 second of Bhavai, which would be the difference between the distance of Ajay and Bhavai. And here the distance is given to us, which is distance of entire track is given to us, which is 150 meter. So distance is given to us as 150 meter, and also the time is given to us. So we just need to find. Okay, so we just need to find the, what we can say, yeah. So we first find the speed and then we just multiply with 15. So we first find the speed of Bhavai. All right. So let me write over here. Bhavai's speed is equal to distance by time. So 150 divided by 75, right? And now we have speed. So it's just 2. So 2 meter per second is the speed of Bhavai. And now we need to find for 15 seconds. So we just multiply this with 15. Sorry for that. So 15 into 2 is equal to 13 meters. So this would be the difference between Ajay, that the Ajay beats Bhavai by 30 meters. So let me mark 30 over here. All right. So 30 as a correct answer. Now we are done with the aptitude section. Now let's move to the programming logic section. And as I can see here, 3 people are watching. So you guys can rate the entire contest on the scale of 10. I would be waiting for your reply. So just write down in a chat that how was your contest. All right. So let's get started with the programming logic quiz section. So the very first problem that we have, given two integers n and k, and our task is to count the number of ways to divide n into k group such that their sum is n and the number of elements in group follows a non-decreasing order. So what I mean by the non-decreasing order, it mean either the follow the linear order or is strictly increasing order. So let me okay, so let me give the example for the non-decreasing. So this would be our non-decreasing sequence 1 1 2 2, because here we have linear order, then strictly increasing sequence. While this sequence 2 2 3 3 1 is decreasing sequence. It's not non-decreasing because here after 3 we have 2 and 1. So I hope the non-decreasing sequence is clear to you. So there are just 5 possible cases. So let me mark all the possible cases. So it's just a simple brute force. You just have to draw the cases, that what are the possible cases, and mark the options according to that. So the very first case that we have, or let me write the value of n as 9 and k as 5. So it means we want to divide n numbers into k group such that every consecutive group is non-decreasing in nature. So the very first group that we can form is 1, 2, 2, 2, and also the sum of the group should be equal to n, which is 9. So this would be our first group. Then the second group is 1, 1, 3, 3. Then the third group that we have 1, 1, 2, 4. Then fourth group 1, 1, 1, 5. And then the fifth group that we have 1, 1, 1, 2, and 4, right? And the sum of every group is equal to 9. And also these groups are non-decreasing in nature, so we just have to mark 5 for this problem. All right, now let's move to the next question. So here basically we have, okay, so what we can say, okay, so here basically we have a dance practice room in a school, and there are 8 practices in the form of interval, that is start I and end I. For the ith practice, where start I is the start time of practice I and end I is the end time or finish time of practice I. And we need to find the maximum number of practices that we can accommodate in a dance room when only one practice can take place at a particular time. And also it was given to us that the start time cannot be equal to the end time of another practice. All right, so you just have to draw these intervals on a number line. So if you draw these intervals on a number line, so you will get the structure something like this. That is, some interval start from some particular number and end at some particular number, and some intervals like this, some interval like this, and this, and like this, and this. And in this way our task is to select the maximum number of disjoint set from here. So if we consider this example, so the maximum number of disjoint sets that we can select is 2 here. We select this interval, and this interval. You can also select this, but we cannot select our two overlapping intervals because these two intervals are overlapping, and it was mentioned that one only one practice can take place at a particular time. All right, so we just have to select our disjoint intervals. All right, so it would be homework for you guys that draw these intervals on a number line and observe the maximum number of disjoint intervals that you can select. All right, so I am skipping this problem, or maybe let me give you answer. So the answer for this problem is 4. And now it's your task to figure out that which disjoint intervals we selected such that we get 4 as an answer. So just draw these start and end points as a on a number line and figure out the 4 disjoint intervals. All right, so let me submit it. Sorry for that. Okay, so we already submitted. Now let's move to the next question. So in this problem, Mr. Reddy is a greedy seller. He has a stock of 8 iPads, which comprises of both useful and useless iPad. Now he want to organize a sale to clear his stock of useless iPads, and the price of 8 iPads are given to us as minus 420, 0, minus 1, 3, 15, and 2. And here the negative value means useless iPads, and in a single day he can sell only 3 iPads. Now Mr. Reddy is being a greedy seller. He want to earn maximum profit out of this sale. So help him to maximize his profit by selling useless iPads. What is the maximum profit that he can earn? So we have minus 40, 20. So let me write over here, or what we can do. Let me take a screenshot. All right. Okay, so basically we have a prices of 8 iPads, and here the negative prices denotes that the iPads are useless, and in one day Mr. Reddy can only sell up to 3 useless iPad, and he want to maximize its profit. So we first figure out that what are the useless iPads we have. So we only have two useless iPad. The first one is this one, for which the price is 4, and here the minus sign indicating that the iPad is useless. And the second useless iPad is this one, for which the price is 1. So the maximum profit that he can make is sum of these two values, that is 4 plus 1, which is equal to 5, and there is no other option, and he can sell up to 3 iPad. So definitely he gonna sell both of them. So the answer is just 5. So let's mark 5. Okay, correct. Now let's move to the next question. Okay, so a major is getting ready for a war. He knows his strength and weakness. He is taking required number of soldiers with him. He can only defeat enemies with strongest and weakest power, and only one soldier can kill one enemy. Your task is to calculate how many soldiers are required by Major to take him with a take him for the war. So the array that we have 1, 3, 5, 8, 11. So we have 1, 3, 5, 8, and 11. So only one soldier can defeat one enemy. So if we select one soldier, then he can only defeat one enemy. That is, we are remain with the three enemies. So this not going to be our answer. That we cannot win the war by just selecting one enemy. So can we select two enemies? Again, the answer is no, because if you select two enemies, or instead of values, let me mark in this way. All right. So if you select two enemies, then this enemy gonna defeat this one, this enemy gonna defeat this one. Again, you are left with one enemy, and you lose the war. So again, two cannot be our answer. So can we select three enemies, three soldiers? Yes, the answer is yes. So if you select three soldiers, so let me change the color. So this soldier can defeat this enemy, and this one defeat this one, and now you are only left with a soldier, not the enemy. So the minimum number of soldiers that we select is 3. So we just mark 3 for this particular case. All right. Oh, okay, so 3 is the correct output. Okay, so now let's move to the fifth question. So here we have given an array A with some elements, and our task is to find the minimum number of insertion to convert the given array into co-prime array into array given array into co-prime array adjacent pairwise. All right. So what I mean by this, so it's basically mean our task is to find the minimum number of elements that we need to insert such that every adjacent elements are co-prime. All right. So let me copy the values. All right. So in this array, our task is to find the minimum number of elements that we need to insert such that every adjacent elements are coprime. And what I mean by the coprime, such that the GCD, the greatest common divisor of coprime numbers are 1. That is GCD of A, comma B is equal to 1. Then A and A and B are coprime. All right. And GCD is nothing but the greatest common divisor. All right. So we first check is 2 and 6 are coprime or not. Here the GCD of 2 and 6 is 2. So these are not the coprimes. So we need to insert an element between them. So we initialize our answer with 0. So we insert our first element here. All right. And it's always possible to insert an element such that the GCD. So let's say we inserted X. So it's always possible to insert elements such that the GCD of 2 and X is 1 and 1 and X and 6 is 1. So it's always possible. And we just need to find the minimum number of insertion. So we insert one element here and then we check the GCD of 6 and 13. So the GCD of 6 and 13 is 1 because 6 and 3 not having any common factors. So we don't need to insert element here. Then 13 and 15, the GCD of 13 and 15 is equal to is also equal to 1. So again we don't need to insert element here. Then we move to the next pair, which is this one, and the GCD of 15 and 21 is equal to 3 because 3 is divided by both the numbers 3 mod. All right, that is 3 mod 15 is equal to 0 and also 3 mod 21 is equal to 0. So it means GCD is not equal to 1. So we need to insert element between 15 and 21. Let's say y. Then we move to the next pair, that is 20 and 21, and the GCD of 20 and 21 is 1. And also a fact here is that the adjacent numbers are coprime in nature. So 20 and 21 are consecutive adjacent, so they are coprime. So we don't need to check for that. So we don't need to insert element here. Then 20 and 22 and 29, again they are coprime. 22 and 29 are coprime. They are not sharing any common factor. So again, we don't need to insert element here. All right. And of course, we would not insert after the last element. So the minimum number of elements that we need to insert is 2. So we just mark 2 as a correct output. All right. Now let's move to the next question. So basically here we have an array A and our task is to check that whether this array represents a binary max heap or not. So I would be giving this problem you as a homework. All right. But let's discuss the approach that how we would solve this problem. So our task is to check that whether this array represents a max heap or not. So just explaining what is the max heap. So for max heap is basically a tree, a binary balanced tree. That is for every child has maximum, every node has maximum 2 children. And in case of arrays, Sorry. Okay, so in case of arrays, and if we index these elements, so this gonna be our 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we think this array as a binary tree, and for every node, let's say the index of node is I, then its left child is going to be at 2i plus 1 index, and its right child is at 2i plus 2th index. So if we talk about this 45, so if we talk about this 45, then the index, its index is 1, so its index is 1, so its left child, that is left child of 45, left child of 45 is at index 2i plus 1. So 2i, which is 2 into 1 plus 1, which is equal to 3. So its left child is going to be this element, and its right child is going to be 2i plus 2, which is equal to 4. And this gonna be its left right child, this one. So 45, then 11 as its left child, and 60 as its right child. And to check that whether the array is max heap or not, it's necessary that for every node, the value of its left child and the value of its right child should be less than the node value. So if I give you the example for this, then let's say we have 9, 5, and 4. So this represents a max heap, because here for every node, and we don't talk about the node for which the left or right child does not exist. So we only consider the node for which the left and right child exist. So for node 9, both node 9 having both its child left and right. So this is representing a max heap, because here the value of both child is less than the node value. Here its left child value is 5, which is less than 9, and its right child value is 4, which is also less than 9. So this representing a max heap. All right. So this representing a max heap, and now let me give you a counter example. So let's say we have 9, then 5, and then 10. So its left child is not violating the condition. That is, its left child having value less than the node value, but its right child having value greater than the node value. So this node is violating the condition. So we simply say that this tree is not a max heap. So we simply return false in this case. And now as we can see here, this node is the node 45 is violating the condition. Its left child, its right child having value less than greater than the node value. So we can say that the entire tree is not a binary, a max heap. All right. So we simply return false, that the given array is not representing a max heap. And again I would say that all these nodes must to satisfy the condition that for every node the value of its left child and the value of its right child should be less than the node value. Then only we can say that the given tree is representing a max heap. And we would all already discussed that how we convert the tree, how we convert the array into tree. For every index I, its left child is at index 2i plus 1, and its right child is at index 2i plus 2 if we consider zero based indexing. And if you consider one based indexing, so this was for zero based indexing. And if you consider one based indexing, or what we can do, let me write over here. If you consider one based indexing, then for every index I, its left child is at index 2I, and its right child is at index 2I plus 1. All right. So as we already saw here that node 45 is violating the condition, so we mark the entire tree as a false, that the tree is not representing a maxi. So we mark false here. All right, correct. Now let's move to the next question. So given an array and k, and our task is to left rotate the array by k indices. So let me copy this. So let's see what is left rotation. So the left rotation is basically means removing this bit or this element from its removing a element from its left and appending it to its right. So let's consider the given array. All right, so this was our given array, and we need to rotate this k time or 3 times in its left. So after the first rotation, the new configuration of array would be we remove this 10 from here and append 10 after 100. Please note that the number of elements in an array will remain as it is after every operation. Sorry for this. Okay. So after first rotation, we get 20, 30, 40, 50, 60, 70, 80, 100, and then 10. We removed 10 from its left and appended after 100. All right. And in next operation, that is second rotation, after the second rotation, the new configuration of array would be 30. We remove 20 from here. We remove 20 from here and append after 10. So 30, 40, 50, 60, 70, 80, 100, then 10 and 20. And similarly, we perform third rotation. And I'm just calling this as a rotation, but the left rotation and right rotation both are the different thing. And since here we are only considering the left rotation, so I'm not calling giving this as a specific name as a left rotation. So if I say rotation, then it means left rotation. So the new configuration of the array after the third rotation would be 40, 50, because in the next left rotation we remove 30 from here and append after 20. All right, so 40, 50, 60, 70, 80, 100, 10, 20, 30, and we just have to perform up till 3 rotations only. All right, so we just have to mark this as our output, which is, I guess, this one. All right, so we have 40, 50, 60, 70, 80, then 100, 10, 20, 70, 80, 90, 100, 20. This one or this one? Okay, it's actually this one, but let me check that where I'm wrong. Okay, so it's actually, I forget that I've actually marked here the value of 70 and 60 was swapped, but here it is correct. And but here also we are correct. We are not doing wrong here. Here. All right. So this is gonna be the correct answer. Now let's move to the next question. So in this problem, here we have an array and our task is to find the number of pairs in the array whose XOR is odd. All right. So we have two options to do this. Since the array is small, so you can also draw the patterns, or you can just take up write down the elements and XOR every element with every other element. But this would take a bit long time. So what I would suggest to write a short program for this and find the number of pairs. So I would be solving this using code. So let me write the code for this. All right. So here I am using a Sublime text. All right. So let me write the code from the very scratch. So include bit.std as our header file, bit.std dot c++ dot h, I guess, yes. Then we are using, our standard namespace std, then int main. Okay, am I doing something wrong? Okay, so not at all. Let me copy from here. Bit.std. Okay, sorry for that. It's not just a C++. All right, now we are done. So what we can do, or maybe let me clear this. So we have an array, and our task is to find the number of pairs in the given array whose XOR is odd. So we first take the array. So to take the array, we first have to take the number of elements in our array. Then we create an array of that size. So let's say int arr, which is name of our array. Then we take array as an input for int is equal to I is equal to 0 till n minus 1. Then we simply take the ith element, right? It's actually arr, not ara. All right, and then for every pair, that is for every zeroth element, we take the XOR with all the other elements. All right. So we are initialize our number of pairs, or we can say count pairs as 0, and then for every element I, we again iterate over all the other elements. But we have to skip the elements that we are considering. That we have to skip the ith element. So if j is equal to I, then we simply continue. Right? Otherwise, what we can do? We can XOR, that is current XOR, XOR the ith element and jth element. That is current XOR jth element. And then we check if current XOR or 2 is equal to 0. That is, if the current XOR is odd, then we simply increment our count pair. That is, we found an happy pair for which the XOR is odd. And then we simply print our count pairs. All right. So return 0 because of int main function. So let's see what are the elements we have. But before that, let's build this. Right. So we have how many elements we have? We have 3, 3, 6, and 8. Yep. So we have 8 elements, and the elements are, okay. So we have 1, then 1, 3, 6, 7, 8, 9, 6, 7, 8, 9, and then 11, 12. All right. So if I build this equation, now you can see here we get 26 as our output. Okay, but here we do not having 26 as our answer. So given an array, and our task is to the find the number of pairs in the array whose XOR is odd. So where we did, okay. Sorry to say, but here we have to consider, because we are considering a pair twice. That is, we are considering I. Okay, let me write over here. So we considered the pair twice. We first considered I and J, and when we are considering J, then we considered pair I and J twice. And in next iteration we consider J and I, but these two are the same pairs. All right. So, and if I build this again, okay, we get 13 as our output, but here still it's not 13. So let me check. Given an array A, and our task is to find the number of pairs in the array whose XOR is odd. So did we miss something? We have 8 elements. Okay. Okay. Sorry. Here I am checking for even cases, but actually for odd, the value of current XOR 2 should be equal to 1. My bad, guys. So here the correct output is 15. So we have 15. All right. So yep, the 15 is the correct output. Now let's move to the next question. All right. So here we have given an array of penalties as fines and an array of truck numbers. These are the truck number, and these were the fines that were restricted on the trucks, and also our date 15. We have also our date 15, and our task is to find the total fine will be collected on the given date. That is, at the date 15, our task is to find the total fine that will be collected on date 15, and the fine is collected from the odd numbers on even dates and vice versa. That is, if the car having even number, then the fine is collected on the odd date, and here the date is odd, so it means the fine would be collected from all the tracks whose number is even. All right. So okay, sorry for this. Yeah. So these were the truck numbers, and these are the fine that were introduced. All right. So the date is 15, which is odd. So it means the fines will collected from the trucks whose number is even. So this is our even number truck. Then this truck is even number. Yes, we only have two trucks with even number. All the other trucks having odd number. So the fine corresponding to this truck is 340, and the fine corresponding to this truck is is 400. So we just have to add them. That is 400 plus 340, which is equal to 740, I guess. Yes. So we mark 740 as a correct output. So, all right. Now let's move to the last question. So I would be skipping these questions because there is some information which I'm missing. All right. So now let's move to the coding problem, which were very interesting. All right. So yes. So let's start with our very first coding problem, which is bit by bit. All right, with a 14% of accuracy. So let's start it, or maybe let me clear this thing. Yes. So basically here we have an array ARR of size n, and our task is to count the number of pairs whose bitwise and bitwise XOR are equal. So the very easy question, you just have to figure out the case for which the bitwise and bitwise XOR are equal. So let's move to the board. So we are taking bitwise XOR and bitwise AND. So definitely we would deal in binary representation of any number. So for 1 and 1, so only there are only four possible cases. When 0 1, then 1 1, then 0 0, and then 1 0. And these two cases are identical, so it's enough to only consider one of them. So we first check that whether for this the bitwise and bitwise XOR are equal or not. So just recall the properties of XOR. Okay. So 0 XOR 1 is equal to 1, but 0 and 1 is equal to 0. So in this case, they are not equal. That is bitwise and bitwise, or bitwise and bitwise XOR are not same. Then the last case that then the second case that we have, when 1 1. So 1 XOR 1 is equal to 0, but 1 and 1 is equal to 1. Again, they are not equal. Then the third case that we have is 0 XOR 0, which is equal to 0, and 0 XOR 0 is 0, and 0 is also equal to 0. So in this case, they are same. And then our last case, but we already checked for this, so again we don't need to check for this again. So for this case also, the and XOR are not same. So the only case when we have when both bits are 0. So it mean ARR of I. So let's say two pairs, pair I, pair I comma J, they having same and same XOR. So this is only possible when ARR of I is equal to 0 and ARR of J is equal to 0. This was the only possible case when for which the XOR and AND are equal. So we only need to consider the element which are equal to 0, and we count the number of elements which are 0. So let's say the number of elements which are equal to 0 is count. Now we just have to check that how many ways to select two number from here, that is C of CNT, number of ways to select two number from CNT. So this was nothing but CNT multiplied by CNT minus 1 and divided by 2. These are the number of ways possible to select two numbers. All right. So let's see. So let's implement this. All right. So we initialize our CNT with 0. Okay, so we initialize our CNT with 0. Then for every element, we check that whether they are equal to 0 or not. That is, if ARR of I is equal to 0, then we increase our CNT. Now we have that how many elements are equal to 0. Now we need to select how many ways are possible to select two elements from CNT. So this is nothing but CNT C2. And if you break this formula, or what we can say, let me write over here. So CNT CNT by 2 is equal to CNT factorial divided by 2 factorial into CNT minus 2 factorial. All right. So this was nothing but CNT into CNT minus not 2 minus 1 divided by 2. Right. So we just simply return, or what we can say, let's write answer here. So CNT multiplied by CNT minus 1 divided by 2. So we simply return our answer. This is going to be our answer. All right. So let's try run. Let's run this program. Okay. Same as expected. Now let's try to submit it. Accepted. Now let's move to the next question. And the second question that we have is empty the string. All right. So basically in this problem, we have an string S, and in one operation, we can delete any occurrence of geek as a substring in the string, and we need to find the number of delete operation we have to perform to make a string empty. So let's take this example. So for this example, the value of S is equal to GE, then geek geek and EK. All right. So in first operation, we delete this substring. We delete this substring because this substring is equal to geek. Now we are left with G G double E K, that is geek. So in next operation, we delete this entire string. Now we are left with empty string, and this is what we want. And the number of operation that we performed is 2. So we just return 2. All right. Now let's take this example. So we have geek, then K, G double E. So we have geek, S is equal to geek, then K double K G double E. So in first operation, we delete this entire substring. Now we are left with K G double E. Now we cannot apply any operation because there is no substring for which is equal to geek. So we cannot apply any operation, and also our string is not empty. So we just return -1. That is, it's not possible to delete the entire string. So we just return -1. So let's see how we can solve this problem. So the best way to solve this problem is stack. And how I come up with this approach. So these kind of approaches is only comes with experience, that how many questions you had solved before, and why I'm using a stack. You will get to know very soon. So let's see. So what we do, we simply start iterating over the character from left to right, and then we check if the current character is si. That is, if si is the current character is k. That is, if si is equal to k, then it means we want the character g double e. Then only we can perform the operation. That is, we want the character g double e, and if the stack contains these many characters, then we simply pop these characters from the stack and move to the next character. And if it is not possible, that is, the stack does not contain g double e, then we are not it's not possible to delete the entire string. And why so? Because there is no other option to delete this k, because this k is dependent on the character in its left, and in its left there must be character g double e, then only we can delete the entire occurrence of geek. All right. And since the stack is restricted with only few operations, so it's helpful to use stack, and also it's better in terms of complexity. For stack, the time complexity to push the element is constant. That is, push operation cost you a constant time, and also pop operation cost you a constant time. So it's helpful to use stack. All right. So let's quickly implement this. So we are going to use a stack of characters, and also it's not possible to delete the character when the length of the character mod 4 not equal to 0, because if that is the case, because we are restricted with the character, we are only deleting the character, we are not allowed to remove the character, and we are deleting the character in group of 4. So it's if it is not possible to divide the group into four parts, then we simply return -1. All right. So we first take the length of character, which is equal to s dot length. Then we declare our stack of character st. Then for every when we iterate over the characters of string s, that is, if si is equal to k, then what we do, we simply extract the last three character of the stack. All right. So if we first check, so here we check that if n mod 4 is not equal to 0, then we simply return -1, because we are only deleting the characters in group of 4s. So if it is not possible to divide this in a chunks of 4, then we simply return -1. Then we check that if the size of the stack st dot size is less than or is less than 3, not equal to, because we need three characters. So if it contains three characters, then it's fine. All right. Then our first character, if st dot size is greater than or equal to 3, else we return -1, because now we do not have three characters to delete the all three characters with k. Then our first character. Okay, so what we can do? Let's mark character c here. So our first character c is equal to st dot top, and then we pop st dot pop. All right. Then our next character is going to be b. Then our next character is going to be c, not c, but actually a. So let me write over here. So what we are doing here, when we get k, then we popping the next three character and check that whether it is possible to delete the substring or not. So this gonna be our character A, then B, and then C. And now we are going to check that whether if A is equal to A is equal to G, B is equal to E, and C is equal to E, then we can delete the entire substring. Otherwise, it's not possible to delete, and we simply return -1. So it's like if A is equal to G and B is equal to E and C is equal to E, then only we can delete the entire substring. Otherwise, and if that is not the case, so here I am taking, I am taking not here. That is if this entire expression is true, then it's fine. Otherwise, if it is false, then we are taking not, then it means this entire boolean expression is true, and we simply return false. Then we simply return false, or you can say -1. That is, it is not possible to empty the string. All right. Otherwise, it's fine. And we already discussed about else case. And if si is not equal to k, then we simply push the current character. That is st dot push is si. All right. And now we need to check that if st dot size, then we simply return -1. That is, if we are left with any character, then we have no other option to delete this character, and we simply return -1. Otherwise, we return n by 4. And why n by 4? Because we are deleting the characters in chunks of 4, and yes, so the number of operations that we perform is n by 4. All right, so let's try to run this. Accepted. But let me explain you this thing. All right, so there might be a case when your s is equal to geek, geek, and g double e. So when you encounter this case, a happy case, in your stack you have three characters for which g is equal to a is equal to g, b is equal to e, and c is equal to e. That means in one operation you delete this, in next operation you delete this, but you in your stack you have these two characters, because after this you didn't get k. So these characters are remain in the stack, and we haven't deleted this. So we simply check that if stack dot size, then we simply return -1. That is, we do not have any other option to delete this. Otherwise, we simply return n by 4. So let's try to submit it. Accepted. Now let's move to the next problem. Okay, so the next problem is connected vertices. So in this problem, we have a list of undirected edges E and a list of vertices B. And our task is to check that we can create that whether we can create a graph using edges in E such that no pairs of vertices in V are connected. So let's take this example. All right. So basically we have some edges and as a list, and we are calling this as E. And what we have to do, and we also have some vertices, and our task is to check that after forming this graph with a graph with these many edges, such that no two vertices are connected, and if it is possible to form it is possible to create such graph, then we simply return true, otherwise no. All right. Okay, so for this example, the value of n is equal to 5. That is the number of nodes, and the number of edges that we have is denoted by m. All right. So these are the edges in our graph we have. So we have 1. There is an edge from node 1 to 2, then edge from 2 to 3, then edge from 4 to 5, I guess. Yeah. Then we have an edge from 4 to 5. And now we need to check that whether these two edges are connected or not. So here 3 and 5, 3 and 4 are not connected. So an happy case, okay with this. Then 4 and then 2 and 5 again they are not connected. Here 2, the node 2 is in this component and node 5 is in this component. So again an happy case. So for every pair of vertices in list vertices they are not connected. So we simply return true for this example. So now let's check. So we have true. Now let's consider this case here. All right. So yes, now let's do solution. So we have an edge from 1 to 2, then 2 to 3, then 4 to 5. I guess again we have same graph. Then there is an, now we check that whether 3 and 1 are connected or not. You can see here 3 and 1 are connected. They are in the same component. So we simply return false because for all the vertices it's necessary that they are not connected. So we simply return false. And while the 2 and 5 are not connected, 2 lies in our first component, then 5 lies in our second component. But still we return false because for all the vertices this condition should be satisfied. All right, so how we can solve this problem? So a very simple approach, that is we break the entire graphs into component. All right, so what I mean by this, so instead of numbers let's assign some values. So this was the initial configuration of the edges, that I am assuming that the graphs that are given to us is forming some components. All right, so these where the components are given to us. So what we can do, we simply iterate over the nodes from 1 to n, and for every connected group we assign some similar values to every node in a particular group. So and for every group we assign some different values. And what I mean by this, so let's say we assign x here, x to this component, this entire group. So we assign every node as a value x. All right, then for the next group we assign some different number, let's say y. So we assign y to every node of this group, or you can say this component. Then we assign some different integer, so let's say z. So we assign z to every node of this component, and then we assign some different value. Let's say what we can say, we consider x, y, z. So let's say a. So we assign a here. Then for this component we assign b here. And once we done with this, then we simply iterate over this list, a list of vertices, and for every list of vertices we check that if they are having these nodes having the same values, then we simply return false, that they belong to the same component. And if that is not the case, then we move to the next pair of vertices, that is we move to this one, and again we check the same thing. And how do we assign the integers here. So you can do any traverser, but it's helpful here to use a BFS traverser because that was efficient in terms of time and also in terms of space. So I am using a BFS traverser to assign the values, some unique values to every component. All right. So I guess this was enough for explanation. Now let's move to the code. So the stream was bit long. So I'm not going to write the code from the very scratch. So let me show you the code for this. Okay, all right. So just okay. So hi, we are back. Okay, so here's the code. That is, we have a function connected vertices that we have to complete and return true if every pair of vertices are not connected with each other, otherwise false. All right. So here we have our adjacency graph or adjacency list. Then we create a graph, and the edges are undirected in nature. So that's why we are pushing the edges in both the directions. All right. Then we have our position, or you can say the values that are assigned to then that are assigned to every node. All right, that is values of every node. Then we have our visited array, which will used to check that whether we already visited the node or not, and if the node is not visited, then only we consider the current component, otherwise not. Then we iterate from I is equal to 1 to n, and here we are starting with 1. So what I mean by this, let me explain you. Okay, so yes. So here I am starting with 1. That is, for the first component, we assign the values 1 to every node of this component. Then for the next component, we are assigning 2. Then for the next component, we are assigning 3, then 4, a new component. And now we start assigning the values to all the nodes of this component as current. The node, we declare our I as visited and the value position of I, that is value of I, as current. And then we simply run our while loop while q does not become empty. It's just a BFS traversal, nothing much. All right, then we pop the element from the front, and then we push the node its neighbor in queue and mark as true and the value as current. That is, we are assigning same value to the every node of the current component. And after this, that is once we are done with the current component, then we move to the next component. So we incremented the value of current, and after assigning the value to each node, we simply iterate over the list of vertices to check that whether they are belonging to the same component or not. So we simply check that if vertex of I0 and vertex of I1 is having same value, then we simply return false. Otherwise, we move to the next pair of vertices, and after processing all the vertices, we simply return true. So let's try to submit it. All right, accepted. So with this, let's wrap up the today's session. Thank you so much, guys, for joining the session. Hope you guys enjoyed the session. And if you are watching the stream recording, then please do hit the like button if you learn something new here. So thank you.